Okay, so this is the second problem on our discussion on solving quadratic inequalities. So remember, the first problem dealt with this inequality here, and so we had a discussion on how to solve this. So we did this long discussion here, and then we saw, once we understood it all, how to quickly do this problem to find the solution. And so remember the process we used, the steps we used were these. So we're going to look at number 2, and when doing number 2, we're going to go ahead and use those steps. And you're going to see that is fairly simple process to solve a quadratic inequality. Okay, so here's number 2, and so I have this quadratic inequality. So you see it's quadratic, but it's an inequality. Okay? And so the first thing you want to do when solving a quadratic inequality is make sure it's in standard form. So you want that 0 on the other side, and we do in this case. Then the next thing you want to do is, if the polynomial is not factored, you want to factor it. So in all of our problems, it will be factorable. Okay? So it will be factorable. So let's go ahead and factor this. So when I factor, I get x minus 3 times x plus 2 is less than or equals 0. So make sure you keep that inequality symbol, though. So these two are the same inequality problem. Okay? Oops, I didn't mean that for it to be 3. I'm sorry. That should be 1 right here. So that's 3, that's 1. Make sure I did this correct. X minus 3, x plus 1. Yep, okay. So now it's correct. Okay, now listen carefully. The next step is to find those zeros. So remember, to find those zeros from our first discussion previously is we have to set each of those factors equal to 0. So my zeros are, all right, now remember, another word from 0 in our previous discussion is critical number or boundary point. So you may see the word critical numbers, you may see the word boundary point. Does not matter. Okay? Your book uses the word 0. Nun Alta uses the word critical numbers. Okay, so my zeros or critical numbers are, and all you do is set each of those factors equal to 0. So I have x minus 3 equals 0, so x equal 3, right? So that's one of your critical numbers. My other critical number, x plus 1 equals 0, solve for x, I get x to be negative 1. So I have my two critical numbers. Once you find your critical numbers, once you find your zeros, you put them on the number line. And make sure you put them in order. If you don't put them in order, you're gonna mess up your solutions. They must be placed in order. So you put negative 1 first, and then you put 3 next. Okay? Negative 1 comes before 3 on the number line. Now I want you to notice that these two critical values divide the number line into 3 intervals. This interval, negative infinity to negative 1. This interval, negative 1 to 3. And this interval, 3 to infinity. What I want you to also notice is this. These critical numbers are called zeros, right? They're called zeros for a reason. They're called zeros because when x is negative 1, it makes this product 0. Watch. Negative 1 and then negative 3 is negative 4. Negative 1 plus 1 is 0. Negative 4 times 0 is 0. So what I would then do at this point is go ahead right here and put the number 0 and put the number 0, because that's what I get. When x is negative 1, this product is 0. When x is 3, this product is 0. 3 minus 3 is 0. 3 plus 1 is 4. 0 times 4 is 0. So always remember to do that. Okay, now what we got to do now, remember, is we got to choose test points to determine the sign of this polynomial. So you're going to pick any number in this interval, any number in this interval, any number in this interval for your test points. So give me a test point that's between negative infinity and negative 1. Let's say negative 3. Give me a test point between negative 1 and 3, and always use 0 if you can. It makes things so much easier for you. So if negative, so is 0 between -1 and 3? The answer is yes. I'm going to use 0. Now you could use any real number you want to in here. If you want to use a decimal or a fraction, you can. It does not matter. I wouldn't do it. I would stick strictly to integers as your test points. Give me a number between 3 and infinity. If you want to say 5, that's fine. Or 4, or 8. Any number between, any real number between 3 and infinity. Okay, so that's where I'm at. Now once you find your, once you pick your test points, then you're going to substitute them into your quadratic polynomial. I would always go back to the factored part. Go back to the factored part. Assuming you did the factored part correctly now, okay? If you're not certain that you did the factored part correct, then you would have to go back to the polynomial here and use your calculator carefully. And I'll do that with this test point 3. I won't do the rest because of our time, but I'll do it with the first one. But here's the way I would do it. So assuming I factored correctly, you're going to substitute this test point into the factored part. Okay, so listen. -3, I'm going to write it out. -3 minus 3 times -3 plus 1, right? Well, -3 and a -3 is a negative. A -3 plus 1 is also a negative. That's negative, all right? Because that's -2. And a negative times a negative is a positive. Now, before I go on, I'm going to ask you this, and I should have asked you earlier. I want this product to be positive or negative. What do I want this product to be? Well, I want this product to be less than 0, so that means negative. But I also want this product to be what? Equal to 0. So I want it to be negative or 0. Okay? So always think about what product you want this to be. I want this product to be less than 0, meaning negative, and then equal to 0, meaning 0. And so when I do my test point, I notice that if I pick any number between -infinity and -1, it's always going to be positive. Is that so? So the question is this interval going to be a solution? The answer is no. Okay, so I'm not going to use it. Okay. Now, I want to remember I said earlier when we started this, I was going to go back and show you if you want to use the original polynomial, you could. Here's what you got to do though. You're going to say -3 squared, that's a -3 squared, minus 2 times -3 minus 3. Well, -3 squared is 9. -2 times a -3 is a positive 6, and then minus 3. 9 plus 6 is 15. 15 minus 3 is 13, and that's positive. And that's what we saw here. Okay? All right. But I would, assuming you factored correctly, I would do it this way. It is so much quicker. Now let's do the next test point, 0. When x is 0, I get 0 minus 3 times 0 plus 1, right? 0 minus 3, 0 plus 1. Well, 0 minus 3 is a negative number. 0 plus 1 is a positive number. A negative times a positive is a negative. Is that interval going to be a solution? The answer is yes. So I'm going to check it. Let's do 5. 5 minus 3 times 5 plus 1. Well, 5 minus 3 is 2. That's positive, right? 5 plus 1 is 6. That's positive. A positive times a positive is a positive. So no matter what value, no matter what test point I use from 3 to infinity, or that's greater than 3, I should say, is going to be positive. Is that something I want? The answer is no. Okay, so I found for the negative part, I found which one works. Now look at the 0. Don't make that difficult. You know already which numbers make this 0. Those right here, your zeros. That's these, right? So this is a 0, and this is a 0. Okay, so you may say, well, how do I use that fact that there's an equal sign in the solution? Very simple. Listen carefully. So there's only one interval, right? Okay, so you're going from -1 to 3. Since there's an equal sign, you must include -1 and you must include 3. So your solution will be bracket -1 to 3 bracket. And that's how you indicate this equal sign. So you -1 is going to make this equal to 0, so hence bracket. 3 is going to make this product equal to 0, hence the bracket. Okay? And that's it. That's all you do. Very simple. Now I want to show you very quickly the graph, and I'm not going to do it for all of them, but at some point you're going to graph this quadratic function right here, this quadratic part. And when you graph the quadratic part, this is what you get. Okay? And so if I were to draw, here's the x-axis, and if I were to draw the y-axis, let's say the y-axis is here, right here. And so what I want to find is where are my y values in terms of this graph. You're looking at the y values. Where are the y values negative or 0? Well, the y values are negative below the x-axis. All these y values are negative. Well, remember your intervals. You have this interval, you have this interval, and you have this interval. So my y values are negative below the x-axis, and this part of the graph is below the x-axis in the interval -1 to 3. So from -1 to 3, my y values are negative. And then where are they 0? Well, they're 0 at -1, and they're 0 at 3. So hence the bracket. Okay? All right, so that was number 2. Very simple. It's not difficult. So let's look at number 3. So you see it's getting a little bit quicker because you're understanding the process a little bit better. So let's look at number 3. So number 3, we have this problem. Let's see. All right, we have 2x squared plus 5x is greater than or equal to 12. So 2x squared plus 5x is greater than or equal to 12. Okay, so I have this quadratic inequality, and first thing you always want to make sure that it's in standard form, meaning you want 0 on the other side. You don't see that here, so you got to bring that 12 over. So I get 2x squared plus 5x minus 12 is greater than or equal to 0. Okay? All right. Then the next step is to factor this quadratic part here. So we're going to go ahead and factor this as 2 binomials. It's always going to be factorable. The ones you have will be factorable. All right, so we're going to factor this. So this factors as 2x minus 3 times x plus 4. So let's double check. 2x times x is 2x squared. Negative 3 times 4 is a negative 12. The outer is a positive 8x. The inner is a negative 3x. And when I add them up, I get 5x. All right, so I factored it correctly. All right, now remember the next step is to find those critical numbers, sometimes called zeros, right? Critical numbers or zeros. And so to find those, we set each of those factors equal to 0. So I have 2x minus 3 equals 0, x plus 4 equals 0. And then I solve these linear equations. So for this one, 2x equals 3, which means x is 3/2. So there's a 0, right? Over here, x equals negative 4. So those are my 2 zeros. So then I put this on the number line. Put on the number line, make sure you put them in order. So negative 4 will come before 3/2. So here's negative 4, and here's 3/2. Oops, I didn't mean this is positive. Let me go ahead and change it to positive. So negative 4, positive 3/2. All right? So notice that these zeros divide the number line into how many intervals? 3 intervals. One from negative infinity to negative 4. Second one from negative 4 to 3/2. And then the third one from 3/2 to infinity. Okay? So if and also I want to make sure that this product this product here is greater than 0, meaning positive, right? So I want this product to be positive. Since there's an equal sign, I also want it to be 0, positive or 0. So I want to find the values for x that will make this product, this polynomial, this quadratic polynomial, positive, greater than 0, or 0, because it's equal to. Okay? All right, so here we go. We pick a test point. So let's say my test point's -6. Over here, I'm going to go ahead and use 0 because 0 is in there. And for this test point, 3 halves is 1.5. So pick a number greater than 1.5. So let's say 3. Okay? So those are my test points. Now remember, you could have picked any number for x that's in here. So you didn't have to choose -6. You did not have to choose 0. You did not have to choose 3. As long as that x value is in here, that x value is in here, and that x value is in that interval. Okay, so we're going to go ahead and substitute these values into our factored part. You can go back and use use a polynomial here, and I'll make sure you use this one, not the original, because this is the one where it strictly says is greater than 0 or equal to 0. So positive or 0. I'm going to go ahead and use the factored part. If you use the factored part, you got to make sure you do that correctly, though, okay? All right, if x is -6, here's what we get. We get 2 times -6 minus 3, right? 2 times -6 minus 3 times -6 plus 4. That's going to be this one. Well, 2 times -6 is a -12. A -12 and a -3 is negative, right? -15. -6 plus 4 is -2. That's negative, correct? A negative times a negative is a positive. So is this interval going to be a solution? Yes, because I want this product to be positive, and any value of x that's between -infinity and -4 will make this product positive. So I'm going to check it off. Now, remember the -4 and 3 halves are zeros, right? So those are your zeros. So that makes this 0. That makes this 0. Okay? So those are your zeros here. In this interval, if I use a test point 0, I get 2 times 0, which is 0, right? So 0 minus 3 times 0 plus 4. 0 plus 4. 0 minus 3 is negative. 0 plus 4 is positive. A negative times a positive is a positive. Is that something I want? I'm sorry. Negative times a positive is negative. Excuse me. Is that something I want? Is that interval going to be a solution? The answer is no. Because no matter what value of x I substitute or I use between -4 and 3 halves, this product will always be negative. I want it to be positive or 0. If x is 3, 2 times 3 is 6, right? So I get 6 minus 3 times 6 plus 4. Well, 6 minus 3 is positive. 6 plus 4 is positive. A positive times a positive is a positive. Is that interval going to be a solution? The answer is yes. So you have 2 intervals, right, as your solution. You always go from left to right. Now, look at this part here. There's an equal sign. So there's an equal sign, you're going to use the 0. I'm going to put the word use. So meaning you're going to have a bracket. Okay? So you're coming from to your solution. Your solution will be -infinity in parentheses. Whenever you're using infinity, -infinity, is always parentheses with it. So -infinity to -4 with a bracket. Remember the bracket is because that equal sign, -4, when x is -4, this product is 0. So -4 is a solution because it makes this product 0. If there's no equal sign, what would go here? If there was no equal sign, just a strict inequality, what would go here? Bracket or parentheses? Parentheses. And then don't forget to say union, and then your next interval is this one. So it'll be from 3 halves with a bracket because of the equal sign. So, oops, I keep putting negative. 3 halves, bracket, comma, all the way to infinity. All right? And that's it. That's all you do. So there's the work. You got to show the work. You can't go from the problem to the solution. Okay? You must show the work. So you got to show this information right here. All right, let's look at number 4. Very simple, isn't it? It's a very simple process. All right, number 4. Number 4, we have negative x squared plus 5x plus 6 is less than 0. Okay, now you got to be careful with this one. In all the other problems, you notice that the coefficient of x squared was positive. This is negative. So be careful when the coefficient of x squared is negative. What I suggest you do, since this coefficient of x squared is negative, is you multiply both sides by negative 1. So to get this to be positive, you multiply by negative 1. All right, so here's what we're going to do. So I'm going to rewrite this over. Negative x squared plus 5x plus 6 is less than 0. So I'm going to multiply this side by negative 1, and I'm going to multiply this side by negative 1. But you have to remember this. Whenever you multiply both sides or divide both sides of an inequality by a negative number, you have to reverse the inequality symbol. Okay, so don't forget to do that. Okay, so I'm going to say it again. Whenever you multiply both sides of an inequality or divide both sides of an inequality by a negative number, and I am, you must reverse the inequality symbol. Okay, so distribute the negative 1. Negative 1 times x squared, negative x squared is x squared. Negative 1 times positive 5x is a negative 5x. Negative 1 times a positive 6 is a negative 6. Is greater than, you must reverse, greater than 0 times negative 1 is still 0. So the solutions to this inequality are the same as the solutions to this inequality. Okay? I'm going to say it again. The solutions to this inequality are the solutions to this inequality. I want you to notice that this is a lot easier to factor than this because of that negative x squared. This is a lot easier to factor than this one. All right, so let's go ahead and factor this now. Don't forget to say greater than 0. So when I factor this, I get x minus 3, x minus 6 rather, x minus 6 times x plus 1. Okay, so that should be correct. X minus 6 times x plus 1. X times x is x squared. The outer is a positive x. The inner is a negative 6x. I get negative 5x when I add them up. Negative 6 times positive 1 is negative 6. Okay, so I factor it correctly. Now remember, the next step is to find your zeros, or your critical numbers. So to find the zeros, or to find those critical numbers, or those boundary points, you set each of those two factors equal to 0. So you're going to say x minus 6 equals 0. So x is 6, right? You're going to say x plus 1 equals 0. So x is negative 1 when you solve for x. So my zeros are 6 and negative 1. So what do y'all do with those zeros now, or those critical numbers? What do I do with it? The next step is to do what? Put them on a number line. So I'm going to put them on the number line. Make sure you put them in numerical order. So here's negative 1, here's 6. Then you get, so notice that these two critical numbers, these two zeros, divided the number line into 3 intervals. Negative infinity to negative 1, negative 1 to 6, 6 to infinity. So we have to determine which of those intervals will be solutions to this inequality. Now here's where you would ask yourself, I want this product to be greater than 0, meaning that I want this product to be what kind of number? Positive. I want this product to be positive. There's no equal sign, right? So it's a strict inequality. So you're going to say just positive. I want this to be positive. Okay, so now we're going to pick test points. So give me a number between negative infinity and negative 1. So you're going to pick a number between negative infinity and negative 1. So let's say negative 3. A number between negative 1 and 6, let's say 0. Between 6 and infinity, let's say 8. Okay? And so I have 3 test points. So you're going to use each one. You're going to substitute it back into this factored part. If you want to go back to this part here, that's fine. Okay? Now, be careful. Don't go back to the original because you're looking for positive. If you go back to the original, the 0 is going to be the same. If you go back to the original, though, you got to look. You're looking for a negative in this case. So be careful. See, this is less than 0, so that's negative. This is greater than 0, that's positive. So be careful with something like number 4. Be careful. All right, so stick with what you changed it to in the end. Now, if you go back to the original, the solution will be the same, by the way. I just wanted you to know that. The solution will be the same. It's just that you're, here you're looking for positive, here you're looking for negative, because your zeros, the zeros here are the same as the zeros there. All right, you just got to be careful. All right, so I'm looking for this product to be positive, or this to be positive. Okay, so if I choose x to be -3, -3 minus 6 is negative. -3 plus 1 is also negative. A negative times a negative is a positive. That's something I want? Yep, so I'm going to check it off. Let's go to 0. If x is 0, I get 0 minus 6 times 0 plus 1. 0 minus 6 is negative. 0 plus 1 is positive. A negative times a positive is a negative. So that means that any number between, any real number between -1 and 6 will make this inequality negative. Is that something I want? And the answer is no. If x is 8, my test point's 8, I get 8 minus 6 times 8 plus 1, right? 8 minus 6 is positive. That's actually 2. 8 plus 1 is positive. It's actually 9. A positive sum of positive is a positive. Is that something I want? Is this interval going to be a solution? The answer is yes. Okay, now, remember, these are your zeros, right? These are your zeros. Those numbers here make this product 0. But, am I going, so you gotta ask yourself, is these zeros a solution, though? Or are they going to be a solution? You know that this interval is a solution. You know that this interval is a solution. But then you ask yourself, are the zeros solutions? Do you see an equal sign? There's no equal sign, right? It's strictly positive. So those are not going to be solutions, which means when you write it out, you're going to put parentheses there. So these are going to be parentheses and not brackets. So your solution then, you're going to say -infinity to -1 with parentheses. Union, make sure this looks like a parentheses. Union, and then 6 to infinity with parentheses around 6. All right, and that's it. And make sure you always write it from left to right, from smallest to largest. So that's why you have to put this in numerical order. So if you have this in numerical order, then this should be correct. So that was number 4. Not very difficult. So let's do another one with the negative. So we're going to do one more because we're already almost at 30 minutes here. So let's do one more. So it'll be number 5. So let's suppose at number 5, I had this. Number 5. We have -x squared minus 3x is greater than or equal to 0. So -x squared minus 3x is greater than or equal to 0. So what I would do in this problem is given them the fact that x squared has a negative coefficient, I am going to go ahead and multiply both sides by -1. All right, and so let's go and do that first. So -x squared minus 3x greater than or equal to 0. So multiply this side by -1. Remember, what you do to one side, you have to do the other. So you have to do this side -1 as well. But I am multiplying an inequality by a negative number. So I got to remember that I've got to reverse this inequality symbol. And so now I'm going to distribute. So -1 times -x squared is a positive x squared. -1 times -3x is a positive 3x. And I'm reversing this, will be less than or equal to, and then 0 times -1 is 0. Okay? All right. So now the coefficient of x squared is positive, so it's easier to factor. So notice, though, that for this one, you're going to factor out the x. So the GCF is x. There's only 2 terms there. So you get x times x plus 3 is less than or equal to 0. And now I'm going to find the zeros, sometimes called the critical numbers or boundary points. So notice, so there are 2 factors. So I'm going to say each of those is equal to 0. So x equals 0, x plus 3 equals 0. And so here's one of my zeros over here. To get x by itself, you're going to subtract 3 from both sides, so you get negative 3. So your zeros are 0 and negative 3. All right, so I'm going to put that on the number line in numerical order. So negative 3 first, 0 next. So notice that those two zeros divide the number line into 3 intervals. Negative infinity to negative 3, negative 3 to 0, 0 to infinity. All right, so I want this. So I want to find the interval. I want to find the interval that's going to make this product, or this polynomial. Remember, less than 0 means negative, or equal to 0, right? So negative or 0. All right, so I already know what makes it 0. I already know that part, don't I? That's this right here. That's these two numbers. So this is 0, this is 0. So I'm going to use those with a bracket in the end. So when I write the solution, those are going to be brackets. All right, now let's use test points. So give me a test point between negative infinity and negative 3 in that interval. So let's say negative 5. What about negative 3 to 0? Notice I can't use 0 here. Remember in the previous problems, we could have used 0 as a test point, but 0 is a 0. So you can't use 0 as a test point. So we got to use another number between negative 3 and 0. So let's say negative 1. And then over here, give me a number that's larger than 0. So let's say 2. So those are my test points. So I'm going to substitute back into the factored part, or you can go back here. Just be careful when you go back to the polynomial part. But I'm going to always use the factored part. So wherever I see an x, I'm going to substitute negative 5. So I get negative 5 times negative 5 plus 3, right? Well, so I get a negative, and negative 5 plus 3 is also a negative. So a negative times a negative is a positive. Is that something I want? Nope. So that's not going to be so this interval is not going to be a solution. Let's go to negative 1. If x is negative 1, I get negative 1 times negative 1 plus 3. Well, negative 1 is negative. Negative 1 plus 3 is 2. That's positive. A negative times a positive is a negative. Is that something I want? Yes. Negative. Let's use 2. If x is 2, I get 2 times 2 plus 3. Well, 2 is positive, right? 2 plus 3 is positive 5. That's also positive. Positive times a positive is a positive. Is that something I want? Nope. I want this product to be negative or what? 0. So the only interval is this one. So your solution, now that's where you have to ask yourself, when I use those zeros, am I going to use brackets or parentheses? No, it's the equal sign. So you can use brackets. So I'm going to go from negative 3 to 0, bracket. And that's it. There's your answer. So any number, any real number between negative 3 and 0, decimals, fractions, rational numbers between here, irrational numbers between here, will be solutions to the original problem. Okay? The solutions to this is this. The solutions to this is also this. Okay? All right. So that is the process of solving quadratic inequalities. Now I'm going to do some more examples in the next video. So these were examples 2 through 5.